Okay, can you hear me? Yeah, good, excellent. Okay, good morning, everybody. This is an absolute pleasure to moderate and to introduce this first roundtable. This roundtable will talk about constellations of small satellites. I think that we will have some time to discuss this concept of a small in these current times. But I would like to just mention a few things that Constel already introduced to put the context of our discussion. So we are seeing worldwide big projects to deploy satellite constellations led by public and the private sector. Examples from Europe are clearly led by the European Commission and the European Space Agency for the development of the space segment, the ground segment, and also the user segment. For instance, Galileo for navigation, positioning, and timing is fully operational right now and shows an amazing performance that has transformed our daily lives in many aspects. Copernicus for Earth observation data and associated services based on the extracted information is opening the possibility to develop outstanding applications, especially fostered since the free data access policy that was triggered. And Copernicus with the Sentinel satellites is also fully operational nowadays. These constellations position Europe at the very top of the space ecosystems in the race to provide data, information, and services that contribute to our better and more sustainable lives. But the initiatives to increase the number of satellites with new instruments and upgraded performance are focusing, for instance, on extending this Copernicus program to obtain new, more, and better information from our Earth. New satellites are under development, and there are also new opportunities to contribute from public and private initiatives. The Copernicus Contributing Missions program is an example of such kind of opportunities, where almost 30 private companies are already providing complementary data, 9 of them from the NewSpace, as announced last June in the Paris Air Show event, 2 of them which are quietly and strongly to the here in Catalonia. Extending the capacities and services of PNT with a new constellation at LEO orbit satellites is also in the plans approved in the last ministerial meeting. And a new constellation for telecommunications is also under development, IRIS², a program with a strong commercialization driver. But these initiatives that are happening in Europe with a strong push from the public institutions and the key participation of the industry go in parallel with several initiatives worldwide, some of them led by private companies with big numbers in terms of satellites deployed in space. On the other hand, these constellations devoted to improve our life on Earth, sustainability on Earth, and mitigation of the climate change effects have also a clear impact on the space sustainability. Sustainability in space on the development of new space infrastructure requires new procedures, coordination among public and private actors, among countries, and a regulatory framework that provides a reference to guide the future development. Europe is leading important steps on this direction, like the SST program, the Surveillance and Satellite Tracking, or the Space Traffic Management program. So we opened the New Space Economy Congress today in Barcelona with a roundtable that covers a hot topic, I would say, a disruptive global change that will represent a revolution in all means, and a topic that connects also with the initiatives that are carried out in Catalonia. With missions launched from Catalonia, this was shortly mentioned also as the new strategy pillars for the development of infrastructures. We are contributing to speed up innovation on satellite connectivity, payloads and sensors, on-board data processing, inter-satellite links, or novel architecture for satellite constellation services. These activities are combined with the support to technologies for the non-dependency of the EU and the participation in initiatives at European level, for instance, on the use of a space of the European chip, for instance, innovative space data products using artificial intelligence, quantum communications, and QKD, together with an innovative ground segment and user segment connected, for instance, with key programs like Destination Earth and the Digital Twin. Nanosatellites are key platforms to contribute to the development of these technologies and also to the development of new applications and services. This is where nanosatellite missions launched and planned from Catalonia provide their highest value. On top of that, new space missions in Catalonia are devoted to contributing to the goals mentioned before for a better life on Earth and a sustainable and growing economy. And this is achieved also by taking advantage of the existing infrastructures like Sentinel satellites looking for complementarities and for the combination of data and services from different platforms. And last but not least, there is an important commitment from Catalonia on space sustainability. In that sense, the entities of the new space strategy responsible for launching the space missions register our intent to sign the charter for the zero debris promoted from ESA and the European Union for protecting the near Earth and astronomy after the release of the zero debris charter on 7th of November this year. And we are also contributing to the discussions for a sustainable growth of constellations organized by the International Astronomical Union, like the one held at the Canary Islands in early October this year. So today, with the roundtable that we are now starting, we would like to clarify and discuss different aspects of this disruptive change and evaluate the motivation, the challenges, and the opportunities. And we will try to cover all the value chain when discussing how constellations are changing the field. In order to talk about this transformation of the space sector, we are honored to have 4 professionals from different companies that can give us their view from different perspectives. We will have the opportunity to hear their views on the mentioned constellations, the technological transformation we are experiencing, the importance of services we can obtain, the contribution of the new space, and the sustainability of the space segment regarding aspects like in-orbit servicing, space debris mitigation, and space traffic management. So with this introduction, I think that we gave the context of topics that we want to touch. And we will start the conversation, because this will end up being a conversation among us. We will start with Carlos Fernández de la Peña. Carlos is the CEO of the company Telespazio Ibérica. He's a physicist with more than 25 years of international experience in management, strategy, and business development, a career that has always revolved around technology and the space sector. He has worked at ESA and in different important companies of the industry, of the space industry. And I would like to start the conversation with a short introduction of Telespazio Ibérica. What are you doing? And I would like you to emphasize the role in the operation of navigation satellites and in the emergency services of Copernicus. That will be our starting point of conversation, and we can continue afterwards with our topics. Yeah.
Excellent. Thank you, Pep, and thank you to the Congress for the invitation to be in this panel. It's an honor to be in this great place. Quickly about Telespazio Ibérica. We are like 150 people, half of them here in Catalonia. The main difference between us and the other space companies in the country have to do with our focus on users and applications. So we are a company that starts with the user demand and need, and we go up into the value chain to find the best resources to provide an actual service that is useful. And this idea of starting in the actual application and going up in the say engineering scale instead of just developing technology that later will be used or not is, I would say, our key difference. Some examples: we are managing the Copernicus emergency service. So whenever an emergency happens in the world, we might have the need to provide really fast results of what happened in this area. We had the recent earthquakes, for example, in Turkey, or the floods in North Africa. So we are able to provide 24/7 response time in these cases. But if you go to more sophisticated or say inspiring, if you like, because space is more than a business, right? As somebody said before, it's inspiring, it's something that we all love. We are leading a mission for quantum key distribution using low Earth orbit satellites. Or we are planning to provide Galileo and communication services in the moon, because the moon is going to be the next great economy in the future. So these kind of projects that are moving us towards providing services to final users using constellations of satellites is what we do. And yeah, happy to be here to discuss all these points.
Excellent. And I will repeat these questions to all of you about the importance. I would prefer if you can continue with this view of what constellations are contributing to do in this scenario.
Yeah, absolutely. So let me give 2 quick definitions. I know we all have a different definition for everything. So for me, new space doesn't mean startup or a small company. New space means fast, means commercial, and means direct to end customer. This is what I think are the 3 ingredients of new space. It's not institutional, it's not public funds, it's not providing something to an intermediary that later do a business. It's going direct to the customer a private customer in a fast way. Second definition, very fast. When we talk about constellations of small satellites, say, if we talk, we are the industry, right? So we all understand each other. But if we talk outside this event, we should be saying, instead of constellations, continuity or continuous service or frequency of service. This is what constellations do, right? Provide us continuity of the service. And when we say small satellite, we mean low capex. So this is cheap investment, if you like, right? This is what we actually mean, constellation of a small satellite. So going to your point, what we see is having revisit and frequency of data both in remote sensing and in quantum key distribution and in Galileo and in all these kind of services is crucial to us. And having it complementary to the traditional large constellations where you invest hundreds of millions in a 2-ton satellite is definitely a complementary thing to these large programs managed by ESA or by NASA or by large organizations. And I think it's very good to have these programs which are adapted to smaller countries or regions so we can lead them ourselves. This is what Catalonia is doing and many other places. And I think it's a great move that helps to create employment and to foster and to advance things. What is happening today in Europe is Europe have realized, because of this environment of complicated international challenges, that we need to be independent in many ways. They call it resilient. Actually, what they mean is we want to have our own capacity ourselves, not depend on anybody outside to become independent. So IRIS², I'm sure Pedro will talk about this, or the new Copernicus that is going to be not only used for science, but also in security and defense activities, or the Launchers initiative with a lot of money flowing to be able to become actually independent in putting objects into space. These are three elements that are key in the European movements, and I think we should all align with this movement. At the same time, we should try to keep the national and regional programs brave enough to try to solve specific problems for people. And then I come back to the initial point. Instead of trying to do everything and to spread too thin, I would say the best strategy is to be able to concentrate on something and solve it. Because if we solve it here, we can solve it everywhere, right? And we can create an actual world leader by having the right people here in Catalonia working on that.
Okay, thank you. Thank you for sharing with us the approach that you would prioritize for this change of the paradigm that we are living, right? We continue with Rafel Jordà, who is the founding director and CEO of Open Cosmos. He's an aerospace engineer by the University Polytechnic of Catalonia with a master in space technologies. Before Open Cosmos, he worked for the largest aerospace company in Europe, where they finance an MBA. He was also part of disruptive startups in the field of space technologies and the launchers in their early careers. And in 2015, he founded Open Cosmos and has directed it since then. Thank you also, Rafel, for being here with us. Okay. And I would like also to hear your introduction about what Open Cosmos is doing and this connection of the NewSpace and the private initiatives to develop constellations and satellites for commercialization purpose, and the role of these constellations in the future of the space infrastructure.
Okay, I'll try to keep it brief so we can have a conversation afterwards. So Open Cosmos, what do? We design, manufacture, and operate satellites that are capable of helping solve some of the biggest global challenges. We are, I think, now well known for our three products. Open Orbit, which is a satellite solution as a service, where we design, manufacture, test, and even operate those satellites in orbit for people that want to exploit the services. Open Constellation, which is probably the product around which I'm going to talk more about during this session, where we literally what we are doing is we are aggregating satellites in a single shared constellation, where each participant can benefit from higher revisit, more abundant data over the region of interest. And the third product is Data Cosmos, is a data platform that enables third-party analytical companies to bring analytical tools in a single environment where we aggregate all of the data that we get from the Open Constellation, Copernicus, and other sources of data to be able to approach those end users, right, in partnership with the industry and many of the people that I see around here. What do I think about constellations? I think LEO constellations is not the future, it's the present, and we are all seeing. When I started Open Cosmos, many of those constellations were seen as the future. Now we can say it's the present, it's reality. What we are looking at doing at Open Cosmos, it's looking at what's the future of those constellations, and we have a very simple concept around it. We believe that the future of constellations is sharing. It's systems of systems, where the utilization of the assets in orbit is maximized. Space debris and waste are satellites or infrastructure in orbit not used. And unfortunately, in the past, this has happened way too often. So what we want at Open Cosmos is not to launch as many satellites as we can, just to make business out of selling satellites. What we want is those satellites to be very useful, to be shared, and to be optimized to reach the actual needs of those end users. That's what drives us. And if I may say, also, just to wrap up, we have been growing very healthily thanks to the help of particularly this ecosystem, the ecosystem that we found in Catalonia and in Barcelona. 15 years ago, I could have been one of the students now sitting in this floor, and I was walking around Barcelona with ideas about what could be done with the space company, right? Today, it's a reality. We have nearly 100 people right now between Barcelona, Oxford, and Portugal. In Barcelona, we are setting facilities where we have over 800 square meters with clean rooms and testing facilities where we are going to be able to manufacture some of the most advanced satellites. And we are really grateful and happy to be here at home, sharing with all of you this great effort and great work actually to bring new space and to bring space technology to just be another tool, right, used by governments, institutions, and companies of all kinds.
Okay, thank you. Thank you for your words and sharing also slightly different views, right, compared to what Carlos was saying before. But this concept of sharing, right, it's pointing solutions, right, about these kind of questions, about the challenges that constellations are putting on all of us. If we move on and introduce Luc Piguet is the CEO and co-founder of ClearSpace, a company based in Switzerland, to clear up space debris. ClearSpace provides in-orbit services to support institutions and commercial operators in accomplishing their space missions safely and sustainable. With his genuine interest in microelectronics, he studied at Haute École d'Ingénierie et de Gestion du Canton de Vaud, at EPFL in Lausanne for a Master in Science, Electrical and Electronics Engineering, and at Stanford University graduate, a School of Business for an Executive Business Program. He also has a seat at ESA, NewSpace Advisory Board, composed of industrial representatives advising ESA Director General on the required evaluation of the agency's role and approach and on the setup of measures and policies to stimulate the commercial European space sector, which I think is a good place to be, right, and to have these kind of discussions. And I would like also to that you can share with us what ClearSpace is, what is doing right now, and what is expected for the future, and what is the role in space sustainability, and how this is connected with this change of disruptive situation that you was telling me yesterday, this disruption of the managing constellations and deploying constellations that we are living right now.
So ClearSpace is a spin-off from EPFL in Lausanne. It comes out of a project that's been going on for a long time. We really started working at EPFL on the question of space debris in 2010 after launching a CubeSat straight into the field of debris of the collision between Cosmos and Iridium. And I think this is really what triggered the very beginning of the work that was led by Muriel Richard at EPFL for many years. And in 2017, we could see those constellations starting to appear. And in particular, there was this event that OneWeb got financed 1.7 billion from SoftBank, which was kind of a noticeable moment in history. I was coming from, at that time, out of Stanford, where I had classmates that were founders in the space industry. And I realized a couple of things. The first is that the space industry was shifting from very large, expensive system to something much more generalized because of the drop of cost of access to space and the miniaturization. And I made the parallel at the time between this and the microcomputer in the 80s, where the microcomputer industry went from the mainframe that only really governments or large companies could buy to a PC you can put on every single table. So we were looking at the time of the situation and realized this industry is going to change substantially in the coming years. At the time we sat together with Muriel and thought, can we continue trying, because our goal was to demonstrate the tow truck in space. We thought that was needed, and demonstrate it by picking up a CubeSat. And the question was, can we continue to do that inside of university, or should we spin off? And our take was, things are going to change so quickly in the coming years that we need to spin off and make a startup. So that's what we did. We created ClearSpace in 2018, and our take was, we will not find any investors. That was our initial take, because everybody would tell us the same thing. Who's going to ever pay to remove a satellite? Well, who would do that, right? Where's your market? Do you have a market, right? And when we started, what we would say to investors that we didn't build a company for 2018. We built a company for 2025 to 2026. And our take was, there's not going to be a tender for any mission to remove a space debris before 23-24. And it happened that in 2018, the European Space Agency issued a tender for that. And at the time, we were 2 employees in the company, and there was a big shock for us. We thought it's way too early, and decided that we're going to submit anyways, right? And so we built an industrial team, submitted a proposal, won the tender in 2019, and today we execute on this first mission, which is really pioneering servicing in orbit, right? And when you're able to pick up a piece of debris, in this case, it's the mission has as objective to pick up the Vespa upper part is a payload adapter of about 2 meters in diameter that is in orbit already. You essentially demonstrate the first core building block for any service in orbit, being able to pick up something, right? And our take is that if you look at the space industry, how is it going to evolve in the coming years? It's a little like, if you make a parallel, it's a little like a very dense motorway network that's been operating for the last 60 years without a tow truck. You have broken cars everywhere, right? You have debris everywhere. And the question is, how should this system operate in 5, 10, 15, 20, 50 years from now? How does it look like? And if you put yourself in the shoes of the inventor of the tow truck for the motorway, everybody would tell you, this is crazy. I mean, you cannot solve this complete problem with one tow truck, right? You need many more. And the point is that at this stage, what we're trying to build is an industry. It's not just a company. It's the beginning of a new way of operating in space. And it's going to take a little time. It's a challenging exercise. But our take is that if we want to make most out of the opportunity of what space holds for us tomorrow, we need to build a system where it's more than just about providing the service, but making sure that we have an infrastructure that is viable long-term, right? And once you integrate that kind of services, you can really rethink the model, how you build a satellite, right? What is a mission profile of a satellite that can be serviced? If you can service a satellite, how do you design it differently? And in the future, maybe, how can you recycle stuff in space and not launch that much mass, right? So there's a lot of those questions, I think, that are going to come up. I think it's a fascinating industry to work in today. Probably the best one right now. I think everybody agrees here. And we're just very eager to see how this is going to move forward and what all the work we do on all the sides here will impact the future of the space industry and the world our kids are going to be living in.
Mm-hmm. And could you briefly answer what is the impact of this Zero Debris Charter that is now being pushed forward?
Yeah,
the rest of the initiative, which is having other
to come back at those predictions we had, where we thought that there's not going to be a tender for space debris removal before 23, 24. The reason why we did that is because we thought that history changes rapidly because of slow-moving underlying trends. You can measure how things change and reach an equilibrium. That suddenly equilibrium change, and then there's big changes happening, right? Where everybody starts agreeing on something, or regulation gets implemented, or other large events happened. And our take was that those events will bring up to 25, 26 because of the way constellations would be accelerating in this period and how this changes the perception launching states have about the risk they have in space, right? They take in space. And our take was, this is going to happen like this. And we thought regulations are really, and international efforts like this will really kick in 25, 26. And what we see today is that those zero debris charter. There's the pioneering role that ESA leads when it comes to zero debris, which is phenomenal. It's truly visionary what ESA is doing on those aspects. And at the same time, we start seeing like the FCC reducing the time authorized in orbit after mission from 25 to 5 years. I have some American colleagues in the team that told me this will never happen just a year ago, right? And the first fine coming out. So you can really see a shift happening, which happens, in our perspective, much faster than anything that we expected. And for us, I think it can be seen as a constraint for constellations. I think it's hope for the future of the space industry. One thing that really struck me at some point is one of the attorneys from ESA talked about the regulation in space, and he shows a picture where you can see a crossing at the street with a lot of cars and red lights and everything, and he says, so if you look at this image, you realize that every single part of this image is regulated. The color of the green light, the color of the red light, the size of the number on the number plate, all the signals are regulated. And the reason why this regulation is in place is to make the traffic more fluid, right? So the question is, how do we operate tomorrow? What kind of a system do we put in place to make sure that the space industry and constellation projects are successful, right? And I think this is really the intent that has to be behind all those initiatives. And to see all those initiatives is phenomenal because it means that we all take the problem really seriously, and that's needed.
Okay, thank you. And moving on, we have our last speaker here in the roundtable, Pedro Pintó from Hispasat. Pedro holds a Master of Telecommunications Engineer at the University Polytechnic of Madrid and an MBA at the IEEC Business School in Navarra, and his professional career has been linked to space, and especially space communications, beginning his career at the European Space Agency and working later at INTA as responsible of communications of Minisat LEO satellite, launched in 1997. In 2002, he joined the Hispasat staff with the mission of leading the beginning of satellite broadband services, and since 2021, he has been the head of new programs with the mission of analyzing and implementing the infrastructures that will make the future of space communications and services a reality. So the same question, what Hispasat is doing, Pedro, and highlighting the information from IRIS Square and these telecommunication constellations that are planned for the future. And what are, as far as you can tell us, what are the opportunities for new entrants from the new space here? And also what is going on the side of QKD and quantum communications, which is also an important aspect that Hispasat is facing.
Okay, Josep, first, thank you very much for inviting me on behalf of Hispasat, and congratulations for the success of this workshop. It's doubling people every year, you know, so like Moore Law, you know, it's incredible. Hispasat, as I guess that most of the people know, is a satellite operator of geostationary satellites. We have 8 satellites in orbit right now, and we started in 1992 with Hispasat 1E, and little by little we were increasing our fleet. Our main services were communication services, I mean, especially video, selling the megahertz, as we say. And this was our zone of coverage normally is, as we are in 30 degrees west and 61 degrees west, is Europe and America especially, okay? And during many years, we were living very well, selling this capacity, contracts of 15 years to big operators, Telephonic and so on. But suddenly the scenario changed. We all know that we are in a disruptive scenario, but not only about the technology, the LEO constellations and so on, but also the actors. The actors has dramatically changed the scene, because we are talking about Amazon, we are talking about SpaceX, As my boss says, they are deep pockets. They have a lot of money, much more money than all the satellite operators, traditional satellite operators all together. So it is clear that a satellite operator has to do something in this scenario, has to change, has to think in the future. So the things that we are analyzing, especially are new kind of business. So we are going down in the value chain. In fact, we were about 150 people about 1 year, 2 years ago. So, and we acquired media networks and also access to go directly to the final users. So we went down in the downstream to the connectivity services, broadband services, and then we are now giving services directly, especially corporate services, energy, to energy, with these companies. But we're analyzing also different infrastructures. We are analyzing also LEO constellations, but the problem with LEO constellations is if you want to give connectivity services, you need hundreds of satellites to give the first bit, and you need an investment of billions of dollars. So we analyze this possibility, especially with small nano satellites, in order to have some constellation that the costs were more or less a geostationary satellite. We tried, but it was difficult to get these numbers at the bandwidth that we needed, in spite of the big evolution of the nano satellite, the deployment, antenna deployment of the new nano satellite constellations, the increase in the power, the most efficiency of the panels, and so on. But it was difficult, so for that reason, we explored the possibility of Iris Square, which is, we'll talk about that, which is a governmental service, and we'll talk later about that. Also, you said that the QKD, we are exploring new applications because the connectivity services are difficult to compete with SpaceX, later with Kuiper, with Amazon, and I guess that the model won't be to provide connectivity and share for that. It will be to provide connectivity so you can use their services, you can buy their products. So at the end, we think that even SpaceX will suffer with that. We will see that. And in any case, we are suffering everybody if we are going to provide broadband services. So for that reason we created the area that I am leading in Hispasat, which is the new programs. The objective is to analyze new space infrastructures for new applications, space applications, disruptive applications. So I am the strange guy in Hispasat in the strange area, even in a satellite operator. So we are analyzing projects of quantum communications. In fact, we were leading the feasibility phase of Caramel project, which is a quantum payload. And the innovation there is that it will be embarked, if everything goes okay, in a geostationary satellite. Normally, we are thinking a LEO satellite. So the innovation is like that. So we don't know if we are crazy or not, but we are going to try, because at the end, we believe in a multi-orbit scheme, not only for communication, but also for quantum communication and quantum distribution of the keys, okay? And also we are in another kind of project with CISA, with Moonlight for lunar communications and so on. So it is clear that from a satellite operator point of view, the traditional geosatellite, we have to think in new things, And if you allow me, talking about the new space, I would like to also to say that what I don't like about the word new space is that it seems that the people that was not working in new space is old space. It sounds that you are innovating nothing, and you are old. And we have to take into account that there has been a very big evolution in the satellites, in the geostationary satellites, during these 20 years. 20 years ago, the geostationary satellite had about 1 gigabit of throughput with all the transponders. Right now, we are talking about hundreds of gigabits of throughput. That means that the cost of megabit, that is the only way to compete with the LEO constellation, has reduced a lot. When I started the broadband services, we charge for 1 megabit 20,000 euros. And right now in the project Único here in Spain, we have about 35 euros for 100 megabit. So it has increased several orders of magnitude, the reduction of the cost. But not only that, this has been thanks to the evolution of KU, KA, because at the beginning it was very difficult to introduce KU, KA and multi-spot KA. But not only that, we have also had a very big evolution in the flexibility of the satellites. Right now, we have normally digital processors in the satellite that can have regenerative services and can have multi-beam connections. This is very important. Okay, so this is very important for having flexibility because you don't know where the users are going to be in 15 years. We are talking about geostationary satellite with a project that takes 3 years to complete when it is launched, and then 15 years for operation. So you need this flexibility. What I say that is that this kind of evolution is used in the NewSpace. When we start to analyze LEO satellites, LEO constellations, we take for granted this technology. We take for granted this big capacity, this multi-spot KA beam, and of course the regeneration and also the routing in the satellite. Because if you design a LEO constellation, it's very important the routing, not only to connect the beams between the LEO satellite, but also between all the LEO satellites. So you avoid a lot of Earth segments. If not, you will need a lot of Earth stations for that.
Okay. So you introduced the topic that I want now to ask the rest of the members of the panel about this. So there will be discussions about cybersecurity, quantum communications in other roundtables today, and tomorrow there will be also discussions about the applications. So now, with the minutes that we have still, I would like the rest of you to talk about the technological challenges that you foresee in this deployment of constellations, and also regarding the quality of what we are doing for considering the services. I mean, what is the risk that we can assume, this distributed risk in constellations? So how many satellites can be lost, to put an example, keeping the services, but also keeping the sustainability of this deployment, right? You see some technological challenges that and I just pointed out these two, but what is your view in that sense? And feel free to intervene when you want.
I'll take a first step.
Okay. Go ahead.
So we are engineers, I think, around this table.
Physicists.
Come on, it's close. You're getting there.
That's what we think of you.
But jokes aside, we love to talk about the technological challenges, right? But I think that the key challenge is commercialization, actually. So right now, I think the way the space industry is working and the pace of innovation and the way at which we are developing, deploying, and testing is the right approach to literally solve nearly any technical challenge we can face. And we just have to see the launch of Starship a couple of days ago to see and how that fast-paced, agile methodology, it's happening, right? And by the way, it doesn't matter, new space, old space. These days, the more you hear talk about new space, it's probably an old space person talking about it, right? It's all about just embracing these new methodologies, these ways of working, and this fast iteration on the technology. So rather than putting the focus on the technology challenge, I would put the focus on the commercialization challenges. And where do I see those challenges? Is one, meeting the needs of the customer quickly and deeply. And that is easier said than done. Customers sometimes don't exactly know what they want and how the product and the solutions that you are going to bring are going to meet their needs. Their needs are constantly evolving, so you need to be able to evolve alongside those needs. And that in space, sometimes it can be sorted through software, through analytics, and through processing, but many other times it also implies quick evolution of the infrastructure, right? Quick deployment of these new solutions, embracing quantum, embracing different technologies to effectively meet the needs of that customer, right? So I think that the key challenge is a little bit of the mindset that I see actually the industry doing, and I'm sure that Geraldine will talk more about this later, which is we have to stop talking about technology and about us, and just start listening to the customer and working very close with them to really do something that is really useful for them.
Okay, thank you.
You can guess I agree with that. We are basically an end user, value-added services or commercialization company. So we are definitely on it, on trying to find, we define ourselves as a space solutions company, right? We try to provide solutions using space as the means. Just let me challenge you a bit, which is, I kind of agree with what you said about there's no technological risk. My impression is that by keeping...
I didn't say there's no technological risk. There is tons, but it needs to be managed.
It can be managed, right?
Developed agile.
The thing is, if I have the impression, let me do quick numbers. I think I have done that a few times before, maybe you have heard. If you look at Planet, they are selling like 150 million per year, roughly. They sell at 100 euro per year and a square kilometer. So it means that they are selling, if you take the list price, 1 million square kilometers per year, which is 1 out of 150 million of the total Earth. It's less than 1% of their capacity. This is what Planet is selling. Let's imagine the list price is never used and is 5%. Still, they have a huge constellation, very expensive to launch and to operate, to use less than 5% of their capacity, right? So these guys are great. They have tons of money, they have great marketing and great sales team, and still they are not able to move the company over this 150. Actually, they have moved to the US DOD to be able to sell more, right, and to be healthy. So the challenge is, if you go to these solutions which have a low technological risk, if you don't play the risk to go to different sensors, to strange satellites that do new things, you will end up like Planet, trying to sell something that can be done, that the risk is low, but still the market is not, buying it, right? So I agree with you. The challenge we have is making users love our data. We need to realize how useful our data is, and maybe it's not as useful as we like, or we want, or we think. Maybe we need to find different types of data or services that are valuable to users, and being able to multiply interaction is going to be the key for the next years.
And Carlos, if I may do a question.
Sure.
What's the solution to the Planet constellation challenge? From an infrastructure perspective, from a constellation perspective.
My take, I think I said before, instead of trying to build a constellation that helps in many different ways, I would create constellations that solve a single problem.
Exactly.
So
it's shared infrastructure. It's a systems of systems, and actually you pioneered it when you were with us at Open Cosmos. And at Open Cosmos, we haven't raised $500 million to deploy our own constellation with a single kind of sensor to cover all of Earth every single day. We've just raised $50 million. We are really, really focusing on the need of those end users and delivering the data where it matters, which is where they are. And with 25 satellites in 4 orbital planes, 24 actually, in 4 orbital planes, the right mix of sensors, you can provide 3-hour revisit. If you are not trying to scan the whole world, if you are just trying to focus on where your customers are demanding that data, you can provide multispectral, hyperspectral, you can mix the kind of data, and then if you partner with people that can extract value from that data through a platform, to great companies like Telespazio, then you can reach a very, very large blue ocean. And I think that we would do ourselves the better services focusing on that blue ocean, just trying to focus on which part of the infrastructure we are doing or which part of the institutional market we are addressing.
I would like to hear, Luc, if you have a final comment regarding these challenges.
Yeah, it sounds to me that a lot of the discussions are kind of comparing what's done in the US to what we do here in Europe, right? And I think that I agree. I think asking the hard question, making sure that you have a product you can sell to the customers, really the important part, and how can you go quickly there, right? And validate it quickly. I think we have nothing to envy to what the US is doing, right? In terms of competences, definitely in terms of technology, neither. We have everything needed here in Europe to actually succeed and be faster than them. The question is, how do we execute on our programs and how do we ask the hard questions? And I'm coming from outside the space industry, so when I came in, it was interesting to observe the dynamics you can see in the discussions. There's different dynamics that you can see. First of all, you have dynamics that you find in any other industry, which is protecting, and that comes a little to the discussion about old space and new space, right? Protecting what your current revenue stream and not being ready to disrupt them, right? So at the beginning of large constellation, you would go in conference and people would say, no, but they will never work, right? What Musk is doing cannot work, or what OneWeb wants to do cannot work because fishes don't use Wi-Fi, right? That was the argumentation. But that's actually just a projected bias, right? It's not understanding what the dynamic is behind it and what they try to achieve. And I think where we can improve in Europe is on asking the hard questions and being ready to disrupt, saying we can disrupt, we can move faster. And I agree with you, you don't necessarily need the same amount of budget, at least not out of the gate at the beginning to do it. But it's possible to do much more per million invested. And I think this comes to how we execute our program, what are the methods we implement, how we move forward aggressively, de-risking and solving hard problems and asking the right questions. And when we started out, I think what made us stand out as a company at the beginning was the fact that we kind of ignored experts around us that told us that what we wanted to do was impossible, right? And when the more you're in an industry, the more you operate, you end up having this kind of tunnel vision that builds up. And then you eliminate a lot of options, or even questions, good questions, and we don't ask them anymore. And one of the challenges I see a lot in the engineering team I've been working with, right, building up ClearSpace, is that it's very easy to fall into this trap and say, oh, no, it has to be done this way, right? And then you go into a very different process, a very different approach, which might just not bring you where you need to go by when. And the hard question is, where do you need to be by when? What is your customer really wanting to pay, willing to pay, right? What is it that really makes a difference, and how can you go there as quickly as possible? What is the next de-risking thing I have to do tomorrow? How do I make it cheaper, faster, simpler, right? And I think introducing this culture into our companies here in Europe is critical in our project, because this is what we need to be able to compete.
Okay. And one sentence from Pedro, because we are running out of time. Okay.
I think the key is if you assume the risk or reduce the risk, okay? Because if you are using codes, it is clear that, for example, for low orbits, it is clear that you are going to reduce the cost, but you have more risk, you can have more failures, okay? So, or you can assume the risk or reduce the risk, for example, via constellations. If you have a constellation of satellite, you can have what we call distributed reliability, that if something fails in one satellite, you can use another satellite. But of course, you need constellations for that. And one very good example is that I guess that it's not very known that 10% of the Starlink satellites are failing, 10%. But nobody knows. Nobody noticed. Why? Because they have so many satellites that via the redundancy of the satellite, they are getting that the service is operational, fully operational.
Okay.
With GEO satellite, we can do that, except the exception of Intelsat. Intelsat has more than 50 satellites. They are not buying the insurance of the satellites. So, which is a big bunch of money, because it's, maybe it's 10 or 20% of the satellite. So if they have some failure, they have money. The money that they have saved, they can put another satellite, or they can reuse one satellite that is already in orbit.
Okay.
Can I add something quick?
We should stop.
Shit.
That's very interesting. Yeah, that's a very interesting conversation. So I would suggest continuing these discussions during the networking, coffee breaks, and so on. Please look for them and discuss this topic, which is quite interesting. And I really thank you for participating in the roundtable. And yeah, we should move on with the next topic. Okay, thank you.
Thank you very much.
Lucky.
Very good.
Sí, me ha caído.
Bueno.